We have 3 new friends to add to our table of friends. Please remember, everything we're doing today is review of stuff that we learned last time. So it's simply review. So Stecker, please tell me something that was new last time. Work. Okay, that's the first one here. First of 3. The name is work. The symbol we use for work is what, Laura?
W.
Capital W. What are the dimensions for work? Wicket.
Joules.
Joules. What is a joule, Andy?
Newtons times meters.
Good. A Newton meter or Newton times meter. What is a Newton in base SI dimensions, Connor?
Kilogram times meter per second squared.
Great. Kilograms times meters per second squared. The equation for work, Connie, is what?
Is it force times
Displacement.
Oh yeah.
That's part of it.
Oh, times cosine theta.
Times the cosine of theta. Work equals FD cosine theta, where F is the force doing the work, D is the displacement of the object. Theta is the angle between what and what, Jessica?
Okay. Between F and D.
Between the direction of the force and the direction of the displacement. With regards to the numbers you use in this equation for force and displacement, what did I specifically identify about what you use for force and displacement? Headland. Well, you remember you're going to use the magnitude of the force and the displacement. It's the cosine of the angle that determines whether it's positive or negative, and you use the magnitude of the force and the displacement. Good. And remember, work is a scalar. Everything that was new last time is a scalar. Leah, give me something else that's new. There's a bunch that was new, just anything new from last time.
Anything?
Just
Conservation of energy.
conservation of energy is actually not going to go on the table of friends. It was a good try.
Oh, yeah, I think you wanted anything.
I did. I figured we could
Okay.
start with anything, and I could say that's not on the table of friends if it wasn't. I mean, the percentage chance of finding something that we're not going to have on the table of friends was pretty low, but you found it regardless. Yes, we did talk about conservation of energy last time, and we're going to use that in a little bit, but that we're not going to head
Oh,
to the
how
table.
about spring constant?
All right, spring constant. That sounds like a good one. Well, that's actually the third one here, the spring constant. The symbol we use for the spring constant, Maria, is what? K. It is a capital K. The dimensions for the spring constant, Lily.
Does it have any?
Yes. It is not a coefficient. It is a constant. Connor, help her out.
Joules.
It is actually not in joules. Leah?
It's over meters.
Newtons per meter. So spring constant is in newtons per meter. What is the equation that we have for the only equation that has a spring constant in it at this point, Mitch?
Potential energy elasticity equals 1/2 K times squared.
So elastic potential energy equals 1/2 K times x squared, where K is the spring constant. What is x in this equation, Christine? But displacement from something specific. No, that's okay. Displacement from what? Great.
Equilibrium position.
The equilibrium position, that is synonymous. We sometimes also use what term instead of equilibrium position? Rest position. So the x is the displacement from the equilibrium position, also the rest position. Just so you know, this equation we're also going to put right here under the umbrella of the other thing that we're going to have. Who could tell me the name, the general umbrella under which we're going to put elastic potential energy? It has to do with the equation that Leah brought up, but. Nick? Kinetic energy is another example, which we'll put over here. Kinetic energy, what is the equation for kinetic energy, Andrew?
I'm sorry.
I'm sorry too. Why don't you try harder than that though?
Let's see here.
See, this only needs to be in your notes. It doesn't need to be in your brain.
Half mv squared. I don't have a notebook with me.
That's sad. 1/2, what does M, Andrew, stand for?
Yes.
V?
Velocity.
Good, we have kinetic energy 1/2 mass times velocity squared. We yet to have the name under which the umbrella name we're going to put for this, Josh. These are both types of mechanical energy. The symbol we use for mechanical energy, Christina? Capital M-E, the dimensions for mechanical energy, Miss Palm? Joules, they are the same as work. We have one other type of mechanical energy, Daniela.
The gravitational friction.
Gravitational potential energy, Daniela, the equation for that is?
MGA.
mgh, where m is the mass, g is the acceleration due to gravity. H, Knickerbocker, is what?
Height is 0 line.
Very close. There's one word missing from that. He said the height from the 0 line. Nick?
Above.
Yeah, I would say, but there's actually one specific one I just want to make sure we get. Sarah?
Vertical height.
Vertical height. Just to reiterate that it is the vertical height above the 0 line. If we just say height, sometimes people wonder if it's along the hypotenuse, but it's always the vertical height above the 0 line.